Hello students, I hope you are all doing well. I welcome all of you for today's class. In our last class, we have learned a definition of square number, we have listed the properties of square numbers, and also we have learned very interesting patterns related to square numbers. Now, let's try to find out the different ways of finding the square numbers for the given numbers. So, firstly, let's try to find out for the 2-digit number and 3-digit number. Say, for time being, let us take the 2-digit numbers. Now, let's try to categorize these 2-digit numbers into 3 cases. We know that whenever you take a 2-digit number, you look at its units place. So, the first case we will take all those units place which is ending up with 0, and the second case we will take all the 2-digit numbers whose units place end up with 5, and the third case the 2-digit numbers where the units place does not have 0 and 5, not any of these two. So, now we are categorizing the 2-digit numbers into 3 cases, and let us go one by one. Let us have a look at the case number 1. I have a 2-digit number whose unit place is having 0. So, whenever a number is given with units place as 0, how do you find out its square number? Let us have a look at that. If you observe these examples, we have 10 square which is 100, 20 square which is 400, 30 square which is 900. So, here we observe that whenever the numbers are having 0 at its units digit, we can find the square of these numbers just by adding 2 zeros to the square of the single digit number. Could you observe that? We had 10 and it became 100, we had 20, the square became 400. So, in this way we can find out the square of a given number whose units place end up with 0. Now, let us go to the second case where a 2-digit number ends up with the 5 in its units place. Yes, any 2-digit number whose unit place end up with 5, we can write it as 10x plus 5, isn't it? Now, let us try to look at its square. So, if you take 10x plus 5 whole square, we can write it as 10x plus 5 times 10x plus 5. Now, by simple calculation, we get it is 100x square plus 50x plus 50x plus 25, which is nothing but 100x square plus 100x plus 25. So, we will take 100x common in the from the starting two terms, which will end up with 100x times x plus 1 plus 25. So, we can write 10x plus 5 whole square as 100x times x plus 1 plus 25. Make a note that x times x plus 1 will be a digit in the hundreds place because it is been multiplied with 100. We will use this expression and then we will try to follow the steps to find out a square of a number, say for example 25. So, what is the step 1? So, if you look at the step 1, let us take the square of the unit digit. So, our unit digit is 5, so its square is 25. In the next step, try to multiply the tens digit with its next digit. Suppose if x is our tens digit, its next digit will be x plus 1. As a step 3, in the final answer, the first 2 digits will have 25 and the next 2 digits are given by x times x plus 1. So, therefore, we have 10x plus 5 whole square which is equal to x, x plus 1, 25 which are written digit wise. Let us try to have some examples for this. Firstly, we will take 15 square. Observe 5 in the units place. So, 5 square is 25. So, the first 2 digits are given by 25. What is the number in the tens place in 15? It is 1. So, the next consecutive number for 1 is 2. So, take the product 1 times 2 which will become 2. So, therefore, the next digit is 2. So, the first 2 digits were 25 and the next digit is 2, therefore, 15 square is 225. Look at another example, we have to find 25 whole square. So, 5 square is 25, so the first 2 digits are filled, we need to find out the digit in hundreds place. Observe the tens digit in 25 which is 2. So, therefore, take the next number, it is 3. So, 2 times 3 is 6. So, the hundreds digit is also filled, we get 625. So, look at the last number 35 whole square, 5 square is 25, what is the digit in the tens place? That is 3. So, multiply with its next number 3 times 4 we get 12. So, write it 12. So here we end up with all the squares of the given numbers whose numbers had 5 in its units digits. So similarly, we can try to find out the squares of any 2-digit numbers which will end up with 5 in its units place. Now let's get into the case 3 where we have the 2-digit number which will end up with neither 0 nor 5. So that means we can write these numbers as 10x plus y, where y will not be 0 and y will also not be 5. So to find out the squares of such numbers, let's make it stepwise. In the first step, find the square of the unit digit. We know that our unit digit was y, so its square will become y square. In the second step, find the numbers from 10x plus y by subtracting y and adding y. So when you subtract y, you get a number 10x. When you add y, we get 10x plus 2y. In the third step, multiply 10x and 10x plus 2y, and when you multiply these two numbers, we end up with 10x whole square plus 2 times 10 xy. In the step 4, add y square to this product. So when we add y square to this product, we actually end up with 10x whole square plus 2 times 10xy plus y square, which is nothing but 10x plus y whole square. So observe, we have started with 10x plus y, and by doing these 4 steps, we ended up with 10x plus y whole square. So let's try to follow the same steps to find out the squares of such numbers. Now let's take an example. Let's try to find out 13 square. Now as per the steps, we get the numbers by subtracting 3 from 13 and adding 3 from 13, because 3 is in its units place. So we got 13 minus 3 times 13 plus 3, and to this product we are adding the square of the number in the units place, which is 3 square. 13 minus 3 is 10, 13 plus 3 is 16, plus 3 square. We get 160 plus 3 square, which is 169. Now let's verify it. We observe that 13 square is equal to 13 times 13 is equal to 169, which is the same that we got earlier. Let's try to observe the second example. We have to find out 19 square. Now obtain these two numbers by subtracting and adding the number which is in the units place. In the units place we have 9, so upon subtracting and adding we get 10 and 28. 9 square is 81 and the product of 10 and 20 is 280. So 280 plus 81, which will be 361. Alternatively, to find this 19 whole square, let's try to add and subtract 1 from that. When you add 1 to 19, we get 20. When you subtract 1 to 19, we get 18. And then whatever the number you have added and subtracted, take the square of it, which is 1 square. So add that 1 square to this product. So we get 20 times 18 plus 1, which is 360 plus 1, nothing but 361. Here let's take up another example. So let's find 83 whole square. In the given number, the unit digit is 3. So find the square of 3. So 3 square is equal to 9. So let's find two numbers by adding and subtracting 3 from 83. So 83 minus 3 is equal to 80 and 83 plus 3 is equal to 86. Let's try to take the product of these two numbers. So the product of 80 and 86 is equal to 6880, and we will add it to the square of the unit digit, that is 9, and thereby we get this square as 6889. So we will take up the next example, that is 78 whole square. Here the unit digit is 8. Here the square of 8 is 64. And now let's try to take the other two numbers by adding and subtracting this 8 from 78. So subtracting 8 from 78, we will get 70, and adding 8 to 78, we will get 86. So the product of 70 and 86 is equal to 6020, plus adding the square of 8, that is 64, we get the sum as 6084. Alternatively, we see that 78 square is equal to adding 2 to 78, we get 80, and subtracting 2 from 78, we get 76. So to the product of 80 and 76, we add the square of 2, which is 4. So we get, so 80 times 76 is 6080 plus 4 is equal to 6084. Students, interestingly, case 2 and case 3 could also be extended to find the squares of 3-digit numbers. So, firstly, let's try to find the squares of 3-digit numbers of case 2. So, we know that in case 2, in the first step, we find the squares in the unit digit, and in the second step, we will take the product of tens with its next digit. And finally, in the third step, we will write the product of tens with its next digit followed with the square of the unit digit. So, now with this, let us try to observe some of the squares of 3-digit numbers of case 2. So, let us observe 105 whole square. Here the unit digit is 5, so the 5 square is 25. So, the number of tens here is 10. So, we can write the product as 10 times 11. So, the product is 110 followed by 25. So, we get the answer 11,025. We will also observe another example, that is 125 whole square. Here the square of unit digit is 25, that is the square of 5 is 25, and here we observe there are 12 tens. Therefore, the product of 12 with its next digit, that is 13, will be 156 followed by this 25. Therefore, 125 whole square is equal to 15,625. And in case 3, we know that in the first step we find the square of the unit digit. In the second step, we will find two numbers by adding and subtracting the unit digit from the given number. And in the third step, we will take the product of these two numbers, and in the final fourth step, we will combine this product along with the square of the unit digit. And finally, in the fourth step, we will add the square of the unit digit to this product. So, now let us try to solve some of the squares of 3-digit numbers of case 3. Let us find 103 whole square. So, the first step is find the square of unit digit, that is 3 square, which is equal to 9. In the second step, we need to find two numbers by adding and subtracting the unit digit from the given number. So, subtracting 3 and adding 3 to 103, we get 100 and 106. In the step 3, we need to find the product of these two numbers, which is 10,600, and in the last step, we need to add the square of the unit digit, that is 9, to this product, that is 10,600. So, we get 10,600 plus 9 is equal to 10,609. We will also observe another example, that is 108 whole square. So, we find the square of unit digit, 8 square is equal to 64. We get the two numbers by adding and subtracting 8 from the given digit. So, that is 108 minus 8 is equal to 100. 108 plus 8 is equal to 116. In the step 3, we find the product of 100 and 116, that is 11,600. In the step 4, we will add 64 to this number, so that we get 11,664. So, therefore, 108 whole square is equal to 11,664. Students, observe the numbers 3, 4, 5. Can we relate these numbers in terms of their squares? Yes, we know that 3 square plus 4 square, that is equal to 9 plus 16, which is equal to 25, but this 25 is equal to 5 square. So, that is 3 square plus 4 square is equal to 5 square. Now, let us observe a collection of 3 such special numbers called Pythagorean triplet. Students, now let us observe the definition of Pythagorean triplet. The collection of 3 numbers A, B, C are called as Pythagorean triplet if A square plus B square is equal to C square. Students, now let us observe some of the examples for Pythagorean triplet. The numbers 3, 4 and 5 forms Pythagorean triplet because 3 square plus 4 square is equal to 9 plus 16, that is equal to 25, which is nothing but 5 square. So, it satisfies our condition A square plus B square is equal to C square. Let us consider another example. The numbers 6, 8, 10 also forms Pythagorean triplet because 6 square plus 8 square is equal to 10 square. In general, we observe that for any natural number m greater than 1, we have 2m whole square plus m square minus 1 whole square is equal to m square plus 1 whole square. So, the numbers 2m, m square minus 1 and m square plus 1 forms a Pythagorean triplet. Observe that 2m whole square plus m square minus 1 whole square is equal to 2m whole square is 4m square plus m square minus 1 whole square is going to be m to the power of 4 minus 2 times m square times 1 plus 1 square. This is by the identity a minus b whole square is equal to a square minus 2ab plus b square. So now we get 4m square plus m to the power of 4 minus 2m square plus 1. So here we write m to the power of 4 as a first term. Upon simplifying 4m square minus 2m square, we get plus 2m square and we are left with plus 1. So here we observe that m to the power of 4 plus 2m square plus 1 is nothing but m square plus 1 whole square. So therefore we observe that 2m whole square plus m square minus 1 whole square is equal to m square plus 1 whole square. Students, now let us try to solve some of the problems based on Pythagorean triplet. The first problem goes like this. Find a Pythagorean triplet whose smallest number is 8. Students, we know that we get Pythagorean triplet by taking the general form 2m, m square minus 1 and m square plus 1. So firstly, m square minus 1 is equal to 8. So m square is equal to 8 plus 1, that is equal to 9, which gives us m is equal to 3. So therefore 2m is equal to 2 times 3, that is equal to 6, and m square plus 1 is equal to 3 square plus 1, that is 10. So the triplet is thus 6, 8 and 10, but 8 is not the smallest number of this. So let us try 2m is equal to 8, then m is equal to 4, and so we get m square minus 1, that is equal to 16 minus 1, that is equal to 15, and m square plus 1 is equal to 16 plus 1, that is equal to 17. So the triplet that we got in this case is 8, 15 and 17. So here clearly 8 is the smallest number. So our answer is 8, 15, 17, which is a Pythagorean triplet whose smallest number is 8. Students, let's try to solve another problem. Find a Pythagorean triplet whose one number is 18. Students, to solve this problem, we know that in general 2m, m square minus 1 and m square plus 1 forms a Pythagorean triplet. So in the given problem, 18 is one number. It could be 2m, it could be m square minus 1 or it could be m square plus 1. So let's try to solve it one by one. So let us first take m square minus 1 is equal to 18. So m square is equal to 18 plus 1, that is equal to 19. But the value of m will not be an integer. So we will try to take m square plus 1 is equal to 18. Again m square is equal to 18 minus 1, that is 17. Even in this case m will not be an integer. So finally let us take 2m is equal to 18. So then m is equal to 9. Thus m square minus 1 is equal to 81 minus 1, that is 80. And also m square plus 1 is equal to 81 plus 1, that is equal to 82. Thus the Pythagorean triplet is 18, 80 and 82. Students, here we end the class. Before we wind up, let's try to recollect what all things we have learned today. So we have learned the methods of finding the squares of 2-digit numbers and also 3-digit numbers. Later, we also studied a special collection of 3 numbers called Pythagorean triplet and also solved problems based on them. So here we end our discussion on squares. But students, we have learnt given a number how to find the square of it. But is the reverse possible? Given a square number, can we find a number to which it is a square? We will answer to this question in our next class. Hope you have enjoyed the class. Have a good day. Thank you.